and this is the 2007 Urban Challenge. Now, why are we doing this? Well, as we all know, cars are unsafe. We drive cars manually today, and in the process of doing so, we kill something like 42,000 people every year on US highways and about 1 million worldwide. And it's largely because of human error. So making cars safer is a chief concern to us as a society and to us at Stanford. Cars are inefficient. They are fuel inefficient. They make inefficient use of highways, and they make inefficient use of our time. Most of us spend more than an hour per day in commute traffic, and something that we shouldn't spend attention on, which is just driving in traffic jams, like this morning on 280. So the idea of a self-driving car is a really big idea that will really change society, in my opinion. Now, the 2005 Grand Challenge that we happened to win was a first step. It was a great step in driving along a desert road, but it was deficient in many ways. A desert road is clearly not representative of the type of traffic situation we encounter every day. So in response to those deficiencies, DARPA has created the Urban Challenge, which is driving in a city. And this is an event that leads up to a big race going to take place November 3rd, somewhere in California, we don't know where, called the Urban Challenge, where in the order of 20 vehicles will race in a city and basically run errands, like a FedEx delivery truck, for example, going from here to here to here. And in the process of doing this, they're going to encounter other vehicles, human-driven and robotic vehicles, and they have to be able to negotiate in these situations. That, to us, is a huge technical challenge, so we really focus on the technical side. We have to build cars that can understand the world, they can understand other vehicles, sense them, perceive them, make predictions, and interact with them. So we have to understand if we come to a stop sign that the other car might be there first, it might want to go first, there are certain rules that govern regular traffic, and we have to be able to adhere to these rules. So we have to make machines that replicate human thinking in that specific domain. And it turns out to be a major challenge. It's been worked on for the last 2 decades in the United States and elsewhere, and this is the first event where we're really testing autonomous vehicles driving in urban situations. So I think it's the next step in a number of steps that will eventually lead us to self-driving cars and safer cars. With that, I welcome you all, and I hand over to Mike Montemerlo, who's been the technical leader this year.
I just want to give you a brief outline, for those of you who aren't familiar, what the site visit is going to look like today. The first step is just taking care of some paperwork that we have to demonstrate the citizenship of the team leader, and everybody has this driver's license is ready to go. Then the first thing is to demonstrate the safety of the robot. So that we have an emergency kill system that we can wirelessly pause or disable the car from outside the car. We have to demonstrate this to DARPA, that we can bring the car to a complete, immediate stop at a speed of 20 miles per hour. You'll see it's going to start over in the far corner of the parking lot and then come down towards our simulated intersection here. And then when it reaches 20 miles per hour, they're going to pause the robot and make sure that it stops within a fixed amount of within a minimum amount of distance. The next step is that the real test, and there's 2 parts to it. There's a navigation test and a traffic test. Navigation tests the basic behaviors of the robot. So can it stay in its lane? Does it stop for stop signs? Can it avoid static obstacles? Can it do U-turns? And can it basically follow the missions that DARPA provides you with? Like Sebastian said, these missions consist of going from checkpoint 1 to checkpoint 5 to checkpoint 9, for example. During that test, there won't be anybody in the car. So they'll be following with a chase car behind, and if there's something goes wrong, they can always hit the pause or the kill button. And the traffic test involves more complicated traffic situations where there's actually 2 human-driven cars on the course at the same time. And you'll see there's going to be a gray Touareg, and there's also a black sedan on the course, driven by Stanford racing team people, and they're going to test more complicated behaviors. For example, intersection precedence is one that we expect to see, so that that Junior waits until it's his turn at the intersection to go. And also, there are stopped cars. The Junior will be expected to come to a safe stop in front of the car, look to see if there's anybody in the other lane, and actually cross the double yellow line and pass the parked car. And that's about all of it.